What do you do when an agent is live but user feedback, telemetry, and backlog trends show it still needs tuning? Hi and welcome. I'm Georgia, lead technical trainer at Microsoft, and in this session we'll cover how to monitor agents and work with performance metrics to improve agent outcomes. Let's get started. By the end of this video, you'll be able to establish monitoring frameworks for AI agents, apply industry tools for observability, analyze backlogs and user feedback for actionable insights, use AI-based diagnostic and tuning methods, and monitor performance metrics to optimize agent workflows. We will start by focusing on recommending the process and tools for monitoring agents. We will explore what to monitor, how to structure your monitoring processes, and which tools in the Microsoft ecosystem will help you keep your agents healthy, compliant, and performing at their best. Monitoring AI agents is not a single-layered task. It requires a multi-layered approach. On the operational health side, you are tracking things like uptime, availability, error frequency, throttling, and processing delays. These are your foundational signals telling you whether the agent is even running correctly. Then you have performance metrics, response time, success rates, tool reliability, and workflow completion rates. These tell you how well the agent is performing its tasks. Your best practice is to define baselines for each of these metrics early so you can detect degradation before users start complaining. Do not wait for failures, monitor proactively from day one. Continuing on multi-layered monitoring view, let's look at quality and usage. Quality and output accuracy means checking whether the agent's responses are appropriate, aligned with your business rules, and free from deviations. This is not just about technical correctness, it is about whether the agent is actually helping your business. Then there are usage insights, volume trends, user adoption rates, feature utilization, and behavioral patterns. Why does this matter? Because an agent with a 99% accuracy rate means nothing if nobody's using it. As a best practice, you need to track adoption just as closely as performance. Make sure you correlate quality metrics with usage data to find patterns that drive real improvements. The final monitoring layer is risk compliance and security, and honestly, this is where many organizations struggle the most. You need to monitor guardrail violations. Are users or the agent itself trying to do things outside of policy? Sensitive data handling is critical. Is the agent exposing or mishandling confidential information? You also want to watch for suspicious activity patterns and overall policy adherence. Here's your best practice. Make sure you build compliance monitoring into the architecture from the beginning, not as an afterthought. Every agent should have guardrails defined before deployment, and every guardrail trigger should generate an alert. Now let's talk about establishing a monitoring operating model. This is where many teams fail because they monitor but nobody owns the monitoring. You need to find roles like ops and data engineer teams. Set up process workflows for incident response so when something breaks, there's a clear playbook. Standardize your metric definitions and create baselines with trends so everyone is speaking the same language. Set a log review cadence, whether that is daily, weekly, or monthly. And finally, document expected agent behaviors and constraints. Without that documentation, you cannot tell if something is a bug or a feature. Guardrails and threshold alerts are your early warning system. Think of them as the smoke detectors in your AI architecture. You need to set thresholds for latency, exception volume, and unusual activity patterns. When any threshold is breached, automated alerts should fire immediately. This is not something you check manually once a week. Create specific alerts for guardrail triggers and tool invocation failures, because these often signal deeper problems. Here's something a lot of people overlook. Monitor for unexpected spikes in prompts. A sudden surge in prompt volume can indicate misuse, prompt injection attempts, or a workflow loop gone wrong. Your best practice is to layer your alerts from informational to critical, so your team is not drowning in noise but never misses a true emergency. Even with great automation and monitoring, you still need human eyes on agent outputs. This is what regular quality evaluations are about. Perform human-in-the-loop spot checks where real people review what the agent is producing. Use scenario-based evaluations to test how the agent handles realistic, complex situations, not just happy path cases. Pay special attention to low-confidence outputs because these are the ones most likely to be wrong or misleading. And always validate alignment with business rules and compliance requirements. Your best practice is to schedule these evaluations regularly, not just when something goes wrong. Quality evaluations are proactive, not reactive. They help you catch drift before it becomes a crisis. Monitoring is only valuable if it drives continuous improvement. Analyze your logs and telemetry to identify failure patterns. Are the same types of errors recurring? That points to a systemic issue. Look at whether users need additional training to interact effectively with the agents. Sometimes the problem is not the agent, it's how people are prompting it. Recommend prompt engineering improvement based on what you see in the data. And if you are using custom models, be ready to propose workflow adjustments or even retraining when performance drifts. The best practice here is to establish a feedback loop. Monitor, analyze, improve, and then monitor again. This cycle never stops. Continuous improvement is what separates good agent deployments from great ones. Let's talk about the tools you'll actually use. Azure Monitor is your core telemetry and alerting platform. It provides application and agent telemetry, gives you dashboards for real-time metrics, and lets you set alert rules for anomalies. It integrates with log analytics workspaces, which is where the real power lives. And there are a lot of use cases. Azure Monitor is not just a tool, it is the foundation of your observability strategy. Microsoft 365 Admin Analytics gives you the adoption and engagement story. It helps you understand agent usage volume across your organization. Which departments are using the agents most? Which ones are not? Tracking adoption and engagement tells you whether your AI investment is actually delivering value. This tool is especially useful for identifying departments with low usage or operational barriers. Maybe they were not trained properly, or maybe the agent does not fit their workflow. You can also measure improvements week over week, which is critical for showing ROI to stakeholders. Your best practice is to review these analytics alongside performance data because high adoption with poor quality is just as problematic as low adoption with great quality. When available, Copilot and Agent Analytics dashboards give you granular insights into agent behavior. You can see agent invocation frequency, telling you how often each agent is called. Task completion trends show whether agents are getting better or worse over time. Common user queries reveal what people actually expect from the agent, which is gold for improvement planning. Productivity pattern insights help you understand peak usage and workflow bottlenecks. And error or guardrail trigger events highlight where the agent is hitting boundaries. Use these dashboards to build a narrative about agent health. The Power Platform Admin Center provides environment-level monitoring, which is essential if your agents run within the Power Platform. You get environment health monitoring so you know if the underlying platform is stable. Connector usage and limits are critical because hitting a connector limit can silently break an agent workflow. Flow telemetry gives you visibility into the automation layer that agents often depend on, and data loss prevention rules impact visibility and show you where DLP policies might be blocking legitimate agent actions. Here's your best practice. Regularly audit your DLP rules against actual agent behavior. Overly restrictive rules can cripple agent functionality, while too loose rules create security risks. For larger enterprises with complex agent ecosystems, centralized observability platforms like Foundry become essential. They centralize multi-system logs and event traces into one place, They provide cross-environment dashboards so you can compare agent performance across different deployments. And they offer AI model execution insights that individual tools may not have. The real value is reducing fragmentation. Without centralization, you end up with monitoring data scattered across 10 different tools. Nobody has the full picture. A single pane of glass view means faster diagnosis, better trend analysis, and more confident decision making. If your organization runs multiple agents across different platforms, advocating for a centralized observability solution should be high on your priority list. Custom dashboards are where you bring monitoring to life for your organization. Use Power BI to build KPI dashboards that track exactly what your business cares about. Heat maps of usage show patterns at a glance, like which agents are hot and which are cooling off. Drift detection visualizations help you spot when an agent is gradually degrading before it becomes a crisis. And compliance trend reports keep governance teams happy. Look at the example health summary here. Sales helper at 98% success with increasing usage. That is great. But finance advisor at 86% with decreasing usage? That is a red flag. Build dashboards that tell a story and prompt action, not just display numbers. Let's pull this together into an enterprise monitoring architecture. There are 5 best practices you should follow. First, always centralize your logs because fragmented logging means fragmented visibility. Second, standardize naming conventions so every team describes their agents and metrics the same way. Third, define clear SLAs for agent responsiveness because without targets, you cannot measure success. Fourth, automate alerting for critical business workflows so no high-priority failure goes unnoticed. And fifth, integrate monitoring outputs into monthly operational reviews so leadership stays informed and invested. Your monitoring architecture should flow from user prompts through agent actions into telemetry storage, then to dashboards, governance review, and back into continuous improvement. Let's move into analyzing backlogs and user feedback of AI and agent usage. This is where the real-world learning happens. Monitoring gives you data, but backlog analysis and user feedback give you meaning. Your backlog typically contains enhancement requests, feature gaps, recurrent issues, user friction points, operational risks, and governance concerns. Feedback sources include conversation transcripts, agent usage analytics, support tickets, internal surveys, and more. The best practice is not to treat these as separate streams. The architects who do this well connect the dots between what users say, what the data shows, and what the business needs. To elevate backlog analysis to a solution architecture level, you need a structured, repeatable framework. Start by categorizing backlog items by domain. Accuracy and reasoning issues like misinterpreted queries or missing context go in one bucket. Knowledge issues like outdated docs or missing articles in another. Performance problems such as high latency or connector throttling, UX issues like confusing flows, integration problems like API failures, and governance items like DLP alerts each get their own category. Why does this categorization matter? Because the tuning action for a knowledge gap is completely different from the fix for a connector failure. Without proper categorization, your team wastes time applying the wrong solutions to the wrong problems. Once you have categorized your backlog, the next step is prioritizing by impact and effort. This is a classic 2x2 matrix, but it is incredibly powerful when applied correctly. High impact, low effort items are your priority 1, your quick wins. Fix those immediately. High impact, high effort items are priority 2. Plan and schedule them into your roadmap. Low impact, low effort items are priority 3. Optimize when possible, but not let them distract from the big stuff. And low impact, high effort items, priority 4. Defer them and reassess later. User feedback signals are rich with insight if you know how to read them. Start by analyzing the frequency of similar feedback. When 10 users report the same issue, that is a volume signal you cannot ignore. Assess the severity of user-reported issues because not all feedback is created equal. A minor inconvenience is different from a workflow blocking failure. Evaluate sentiment indicators in transcripts since frustrated language patterns often signal deeper problems. Identify where user expectations diverge from actual business workflows, because sometimes the gap is in the agent and sometimes it is in the process itself. And always consider user suggestions for improving agent guidance. Conversation transcripts are a goldmine for understanding agent behavior. They show you exactly where the agent misunderstood user intent or where users abandoned a flow out of frustration. You can detect incorrect reasoning steps, spot missing knowledge, content that the agent should have had, and recognize workflows that consistently require human intervention. The best practice is to extract common failure paths and map them to root causes. From these patterns, recommend specific improvements, training updates for the model, knowledge source additions, guardrail adjustments, or action limits. This transcript analysis is how you turn feedback into engineering requirements. Here are the key items you should actively monitor for agent usage and behavior. Track usage trends and adoption to understand growth. Monitor peak usage periods to plan capacity. Identify the most triggered intents to know what users rely on most. Watch for high failure prompts because these are your biggest improvement opportunities. Track actions invoked per session to understand workflow complexity. Monitor guardrail intervention events and data access denials to ensure compliance, and always keep an eye on performance and latency. The health summary table here tells a clear story. Finance assistant is doing well, but analytics coach needs a bit of attention. The best practice is to set up automated weekly reports on these metrics so nothing slips through the cracks. All the monitoring and analysis we have discussed means nothing if you don't close the loop and turn insights into action. Design a feedback to improvement pipeline that consolidates backlog and user feedback, aligns items to your enterprise strategy, defines measurable outcomes, creates improvement releases, and validates these improvements post-deployment. Finally, it monitors for drift and regression. It is a continuous cycle. The best practice is to make this pipeline visible and accountable. Assign owners to each stage, set timelines, and report progress to stakeholders. Closing the loop builds trust and drives adoption. Embedding continuous improvement means making it part of your operational DNA, not a special project. Refresh knowledge sources regularly because stale content leads to stale answers. Standardize prompts and flows so improvements are consistent across the organization. Improve orchestration logic when you find bottlenecks or redundant steps. And update integration touchpoints as APIs and connectors evolve. And implement new guardrails based on emerging risk patterns. On the stakeholder communication side, regularly report on top backlog themes, improvement plans, usage insights, performance changes, risks, and expected outcomes. This is the cycle you own. Your best practice is to ensure each stage has clear inputs, outputs, and owners, and that the cycle time is measured and continuously shortened. Faster cycles means faster improvements. In this next section, we will focus on applying AI-based tools to analyze and identify issues and perform tuning. This is where we move from understanding the problem to fixing it. AI agents operate in dynamic business environments, and their performance is influenced by multiple factors: model quality, data condition, workflow orchestration, and user behavior. Effective tuning requires visibility into all layers of agent operation. The key analysis domains are operational health, covering latency errors and throttling; quality of reasoning, focusing on accuracy and relevance of answers; knowledge coverage, checking the completeness and freshness of grounding content; user experience, addressing misunderstood queries and friction points; and governance and compliance, signals, tracking guardrail triggers and security violations. Your best practice is to never diagnose in isolation. A problem that looks like a model issue might actually be a data freshness problem, or what seems like poor user experience might be a governance restriction doing exactly what it should. A structured diagnostic workflow is essential for consistent issue analysis and faster root cause isolation. Follow these steps. Start from user behavior to understand what triggered the issue. Move through telemetry and logs to gather evidence. Categorize the issue by domain. Perform root cause analysis to identify the true source. Apply tuning actions based on your findings. Validate the fix to make sure it actually worked. Then deploy the change and continue monitoring to catch any regression. The best practice here is consistency. Use this same workflow every time. When your team follows a structured approach, you get faster resolution, better documentation, and a growing knowledge base that makes future diagnoses even easier. Do not improvise your way through incidents. Understanding common root cause categories helps you diagnose faster. Model or prompt issues show up as misinterpretation or insufficient context in responses. Knowledge gaps mean the agent does not have the right organizational content or the files are outdated. Integration failures involve connector constraints, API limits, or data access rules, breaking the workflow. Configuration issues are the sneaky ones. Incorrect environment variables, feature toggles, or rule settings that silently cause problems. And governance interference, things like DLP blocking or sensitivity labels, can prevent agents from taking legitimate actions. The best practice is to build a diagnostic checklist based on these categories. When an issue comes in, systematically rule out each category rather than jumping to conclusions. To analyze agent behavior effectively, you need to know where to look. A telemetry deep dive should focus on 4 key areas. First, repeated failure patterns. If the same error keeps occurring, that is systemic, not random. Second, high-volume queries with low satisfaction. These are places where lots of users are hitting the agent but not getting what they need. Third, tasks requiring human intervention. Every time a human has to step in, that is a missed automation opportunity. And fourth, spikes in guardrail enforcement. Sudden increases might mean the agent is trying to exceed its boundaries, or that policies are too restrictive. Always look for patterns over isolated events. Single failures are not noise, repeated failures are signals. User feedback and transcript analysis complement what telemetry tells you. Conversation logs reveal things that metrics cannot capture, like misaligned intent detection, where the agent understood the words but missed the meaning. You'll find ineffective responses that technically answered the question but did not actually help. Repetitive misunderstandings highlight areas where the agent consistently stumbles, and workflow abandonment points show where users gave up entirely. The best practice is to establish regular transcript review sessions with your team. Human reviewers catch nuances in conversation quality that no dashboard can surface. Combine transcript insights with telemetry data for a complete picture of agent health. The transcript review framework gives you a systematic 5-step process for analyzing conversation logs. Step 1. Identify the triggering user goal. What was the user actually trying to accomplish? Step 2. Review the system interpretation. How did the agent understand the request? Step 3. Compare the output versus expected behavior. Did the agent deliver what it should have? Step 4. Mark friction points where the interaction break down or become frustrating. Step 5. Propose improvements, whether that is knowledge updates, behavior changes, or workflow redesigns. As a best practice, this framework ensures you are not just reading transcripts casually, you're conducting a structured analysis that produces actionable recommendations. The Agent Performance Metrics Scorecard is your comprehensive view of agent capability. Here you can see some metrics you can measure. Your best practice is to set targets for each metric and review them regularly. A scorecard without targets is just a report. With targets, it becomes a management tool that drives accountability and improvements. Let's talk about tuning strategies, starting with knowledge and behavioral tuning. Tuning means adding or updating knowledge files to fill content gaps, removing outdated or irrelevant information that could confuse the agent, and refining the knowledge structure for better clarity and retrieval. Behavioral tuning involves adjusting orchestrations or agent steps, adding clarifying instructions to reinforce expected behaviors, and introducing fallback strategies for when queries are ambiguous. The best practice is to tune knowledge and behavior together, not separately. And always test your tuning changes in a staging environment before deploying it to production. Untested tuning is just guessing. Performance and governance aligned tuning round out your tuning strategy. For performance, optimize connectors and external data calls, because these are often the biggest latency contributors. Reduce unnecessary steps in workflows since every step adds processing time and potential failure points. Address slow processing logic or oversized payloads that bottleneck the system. For governance-aligned tuning, review your DLP policies, sensitivity labels, and access rules to ensure they match current business needs. Align agent capabilities with enterprise compliance requirements and critically ensure that logging and auditing remain intact after any changes you make. This issue mapping chart is a practical reference tool you should keep handy. Your best practice is to use a mapping like this as your first diagnostic step. When an issue comes in, check the chart to quickly narrow down the likely cause and appropriate tuning action. It saves time and ensures you are applying the right fix to the right problem. The AI continuous improvement loop is the heartbeat of effective agent management. Here's the critical best practice. Never skip the validation step. Too many teams go straight from tuning to release and discover in production that their fix created new problems. Validate in a controlled environment, compare metrics before and after, and only then publish to production. This loop should be fast, frequent, and rigorous. In this next section, we'll focus on monitoring agent performance and metrics. You might think we have covered monitoring already, but this unit goes deeper into the specific metrics frameworks and processes that define how solution architects should think about ongoing performance management. Why does monitoring matter so much? Because without it, you are flying blind. Effective monitoring ensures agents behave predictably in production, which is the baseline expectations for any business-critical system. It ensures performance degradation is detected early, before users start experiencing problems. It maintains the quality of reasoning, grounding content, and actions consistently over time, not just at launch. Usage insights from monitoring inform your iteration cycle, adoption strategy, and capability refinement. And monitoring ensures governance and compliance requirements are continuously met, not just a deployment. Your best practice is to design monitoring into the agent architecture from the beginning. Let's break down the core operational metrics every architect should track. Latency is the time taken to process agent requests. Users notice latency immediately, so set tight targets. Throughput measures the volume of completed runs over a period. This tells you about capacity and scalability. Error rate is the proportion of failed or incomplete tasks. Even a small increase in error rate can indicate a growing problem. And resource utilization covers compute, memory, and token consumption. This is directly tied to cost and efficiency. The best practice is to track these metrics not just as averages, but also as percentiles. The 95th percentile latency tells you more about user experience than the average does, because it captures the worst experiences real users are having. Quality and reasoning metrics go beyond operational health to measure how well the agent actually thinks. Response accuracy checks alignment with expected or validated outputs. This is not just right or wrong, it is a spectrum of how helpful and precise the answers are. Knowledge coverage measures the agent's ability to surface correct domain content. If the agent does not know something, it should acknowledge the gap rather than fabricate an answer. And action effectiveness tracks completion of multi-step tasks as intended. An agent that completes 3 out of 5 steps is not effective. It is partially broken. The best practice is to create a validation dataset of expected outputs and regularly test your agent against it. This catches quality drift before the users do. User-centered metrics tell you the human side of the story. Satisfaction indicators come from user feedback trends and sentiment analysis. Happy users come back. Frustrated users can stop using the tool. Abandonment rate measures drop-off during agent workflows. If users consistently bail at step 3 of 5 in a process, something at step 3 is broken or confusing. Task completion rate tells you whether users actually achieve what they set out to do. Here's an important best practice. Combine these user metrics with your operational and quality metrics. Let's review the tools available for monitoring. Microsoft provides several purpose-built options: Azure Monitor for call telemetry and alerting, Microsoft 365 Admin Analytics for usage and adoption trends, Copilot and agent dashboards for agent-specific insights, and Power Platform Admin Center for environment-level monitoring. Third-party and Foundry-like solutions also play a role, especially in complex enterprise environments. The key is that no single tool gives you the complete picture. You need to analyze monitoring components across platforms and combine the data for a full view. Map each monitoring objective to a specific tool and data source. Then build integration points between them so your dashboards reflect cross-platform reality. Even when your agent logic is perfectly stable, model-driven behavior can shift over time. You might see shifts in response patterns, declining accuracy in recurring tasks, or increased hallucination and off-topic responses. Token consumption is another critical area. Watch the cost-to-performance ratio and the efficiency of your prompting patterns, including whether thick versus thin prompts perform differently. Reliability indicators like sudden latency increases or changes in the model selection effectiveness, and it can signal backend issues. Your best practice is to establish baseline metrics for model behavior and set up automated drift detection. Do not assume that because the model was fine last month, it's fine today. This diagnostic table is your quick reference for common issues. Incorrect responses from missing or outdated knowledge? Update your grounding content. Slow responses from heavy workflows? Streamline the logic and adjust orchestration. Action failures from connector or AP constraints? Fix the connector issues and update permissions. High abandonment from confusing steps? Improve the UX flow and prompt clarity. Guardrail violations from policy mismatches? Adjust DLP, sensitivity labels, and allowed actions. Your best practice is to categorize every incoming issue using this framework before attempting a fix. Jumping straight to a solution without proper categorization leads to misdiagnosed problems and wasted effort. Disciplined diagnosis equals efficient resolution. So before we wrap up, let's talk about interpreting telemetry data for performance and model tuning. This unit ties everything together. Telemetry breaks down into 4 key categories. Operational telemetry covers latency, throughput, error rates, failure modes, resource consumption, and throttling. This is your system health baseline. Model-level telemetry tracks token usage and cost patterns, response consistency, and drift indicators and degradation trends. This tells you whether the AI model itself is behaving well. These 2 categories are your technical foundation. Your best practice is to establish clear thresholds for each metric and set up automated alerts when those thresholds are breached. Proactive alerting based on well-defined thresholds is the difference between catching an issue in minutes versus discovering it in days. The other 2 telemetry categories are equally important. Behavioral telemetry covers user satisfaction and completion rates, prompt patterns and abandonment rates, and model alignment to intended tasks. This tells you the user experience story. Governance signals include guardrail interventions, blocked actions, or restricted data access and policy or sensitivity label conflicts. This tells you the compliance story. Your best practice is to build correlation rules between these categories. When interpreting performance signals, always focus on patterns rather than isolated events. A single latency spike is noise. A trend of increasing latency is a signal that demands investigation. Increased latency may indicate heavy workloads, inefficient prompts, or resource contention. Spikes in error rates often point to integration failures or configuration changes that broke something. High token usage suggests verbose outputs or unnecessarily complex workflows eating into your budget. Your best practice is to build trend analysis into your routine. Look at week-over-week and month-over-month comparisons. Use the performance signal map to link what you observe to possible causes and the specific actions needed. Model tuning focuses on improving response quality and reliability through 4 key opportunities. Prompt refinement means improving instructions, constraints, and expectations, so the model produces more predictable, useful results. Knowledge updates involve adding, removing, or restructuring knowledge sources for better grounding, ensuring the agent draws from accurate and current information. Behavioral adjustments introduce fallback logic, clarifying actions, or refine orchestration flow to handle edge cases better. And cost optimization reduces unnecessary token usage and optimizes invocation structure without sacrificing quality. The best practice is to tune one dimension at a time and measure the impact before moving to the next. Changing everything at once makes it impossible to know what worked and what didn't. The telemetry-driven diagnosis workflow is your step-by-step process for turning data into action. Start by monitoring key metrics: latency, throughput, quality, and satisfaction. Then identify anomalies by detecting deviations from expected patterns. Correlate related signals by combining user behavior data, failure patterns, and performance trends. Then determine the root cause, whether it is model-based, integration-based, or prompt-based. Apply targeted tuning using the appropriate strategy for that root cause. And finally, validate improvements by comparing telemetry before and after tuning. The best practice is the last step, validation. Never assume your tuning worked. Prove it with data. Compare the same metrics over the same time window and confirm the improvement is real, not just a random variation. Performance KPIs for AI systems should be clearly defined and aligned with business goals. Responsiveness means the median response time stays within acceptable limits, not just the average, the median, because it better represents typical user experience. Accuracy and relevance ensure model outputs align with task expectations. Reliability means a low failure rate across all workflows, not just the happy paths. Cost effectiveness balances token usage and model selection so you are not overspending for the quality you need. And user outcome completion ensures users actually finish their tasks without needing to escalate to a human. The best practice is to tie each KPI to a specific business outcome. Latency is not just a technical metric, it directly impacts user productivity and satisfaction. Let's review what we have covered in this video. You have learned how to establish monitoring frameworks that give you complete visibility into AI agent operations. You can now apply industry tools like Azure Monitor, Power Platform Admin Center, and analytics dashboards for comprehensive observability. You understand how to analyze backlogs and user feedback systematically, using structured frameworks to turn raw input into prioritized improvements. You know how to apply AI-based diagnostic and tuning methods, from knowledge updates to behavioral adjustments to governance-aligned changes. And you can monitor performance metrics and interpret telemetry data to continuously optimize agent workflows. We've covered a lot in this session. There are many ways to continue your learning journey. Keep the momentum going by exploring the rest of the videos in this course or discovering your next favorite topic on Microsoft Learn at aka.ms/learn. Thank you for watching, and remember, impactful AI isn't just built, it's adopted, scaled, and sustained.